Section 3.5, the 5-number summary and box plots. In this section, we'll look at these two objectives. Objective 1, we want to compute the 5-number summary. The 5-number summary of a set of data consists of the smallest data value in the set, Q1, the first quartile, the median, or the second quartile, Q3, the third quartile, and the largest data value in the set. We organize the 5-number summary as follows. So let's look at an example. Every 6 months, the United States Federal Reserve Board conducts a survey of credit card plans in the U.S. The following data are the interest rates charged by 10 credit card issuers randomly selected for the July 2005 survey. We want to determine the 5-number summary of the data. So here we see our data with the interest rates. The first step, we want to write the data in ascending order. We see that the smallest number, or the minimum, is 6.5%. The largest number is 14.5%. Our first quartile is 12%. The second quartile is 13.6%. Remember that that is the median, which is the middle value of the number in the 5th and 6th position. So we find the median between those two values to get the second quartile. And then the third quartile is 14.4%. And so our 5-number summary is listed here. So let's look at how we could do this using technology. The first step is to enter the raw data in List 1 by pressing Stat and selecting Edit. We already have values in our list, so we'll clear them out by arrowing up and hitting Clear and Enter. And we do the same with both lists. Now we enter the raw data in List 1. Once we have all of our raw data in the list, we press Stat again, highlight Calc, and hit Enter on one variable Stats. Now from the home screen, we simply press Enter. And we see the arrow down at the bottom, so we'll simply arrow down until we get to the bottom of our list. And notice that the last 5 numbers are the 5-number summary. Our minimum value, Q1, Q2, or the median, Q3, and our maximum value. Objective 2, we want to draw and interpret box plots. To draw a box plot, the first step is to determine the lower and upper fences. Remember, the lower fence is Q1 minus 1.5 times the IQR, and the upper fence is Q3 plus 1.5 times the IQR, where the IQR is Q3 minus Q1. Step 2, we draw a number line long enough to include the maximum and minimum values, and insert vertical lines at Q1M, the median, and Q3. We enclose these vertical lines in a box. Step 3, we want to label the lower and upper fences. Step 4, we draw a line from Q1 to the smallest data value that is larger than the lower fence, and draw a line from Q3 to the largest data value that is smaller than the upper fence. These lines are called whiskers. Step 5, any data values less than the lower fence or greater than the upper fence are outliers and are marked with an asterisk. So let's look at our example of our Federal Reserve Board with our 10 interest rates charged by our credit card issuers. We want to construct a box plot of the data. So here's the data again that we saw before. And remember, we already have the 5-number summary for this. So recall that Q1 was 12 and Q3 was 14.4. So we want to calculate the lower and upper fences. The IQR will be 14.4 minus 12, or 2.4. The lower fence is Q1 minus 1.5 times our IQR. So when we evaluate that, we get the lower fence as 8.4. The upper fence is Q3 plus 1.5 times the IQR. So when we evaluate that, we see that we get 18.0%. So step 2, we want to draw our number line long enough to include the maximum and minimum values, which remember was 6.5 was our minimum and 14.5 was our maximum. Then we'll insert vertical lines at Q1, the median, and Q3. So we have a vertical line at 12 for Q1, 13.6 for the median, and 14.4 for Q3. Step 3, we want to label the upper and lower fences. So the lower fence was at 8.4, and we see we have our square bracket there. And the upper fence is 18.0, so we have a square bracket there. Then we will draw our line from Q1 to the smallest data value that is greater than the lower fence. So we draw our line down to 9.9, and then we draw a line from Q3 to the largest data value that's smaller than the upper fence. So the largest data value is 14.5. And so we have our whiskers here. And notice that we had a value, our lowest value of 6.5, which was smaller than our lower fence. So this would be considered an outlier, and we've denoted it with an asterisk. So here we see our box plot for the data. So let's look at drawing the box plots using technology on our calculator. The first step is to enter the raw data in list 1. So we press Stat and hit Enter on Edit. And from our previous example, we see that the data is already there. Once the data is there, we press the second button, or the orange button, and then the Y equals key, which is directly above it, and select the first plot by hitting Enter. We want to turn the plot on, so we hit Enter on the On button, and then we use the cursor, so we arrow down. We want to highlight the modified box plot icon. So we keep arrowing over to the right until we get to the middle of the second row under Type, and we hit Enter on it till that's highlighted. Next we press Zoom, and then press 9 for Zoom Stat. So I'll arrow down to it till you see the number 9. So you can see that it says Zoom Stat, and we can either hit Enter on it or just hit the number 9. And we see it drew a box plot for us. Now we can press Trace to toggle between the values, and we see our 5-number summary listed as we go between the values here, just arrowing left and right. Let's look at using a box plot and quartiles to describe the shape of a distribution. So here we see pictures of 3 different distributions. And we see the histogram at the top, and then we see the box plot at the bottom. Notice that in the first picture, the histogram is skewed right. And in the box plot, we can tell that it's skewed right because the right side of the box is larger than the left, and the right whisker is longer than the left whisker. In the middle picture, the histogram is a symmetric histogram. We see that our box plot is also symmetric. It's exactly divided in half. Both sides are equal of the box, and both whiskers are the same length. And then in our last picture, we see the data is skewed left, and we notice that our box plot is skewed left. The left side of the box is larger than the right, and the left whisker is longer than the right whisker. So our interest rate box plot indicates that the distribution is skewed left.